Sine, cosine, and tan allow a tangent allow us to find the lengths of other sides when we know what the degrees of one of those non-90 degree angles is. But if we don't know that, we can use what's called the inverse of each of these, which looks like that. I'll show you in the calculator. We can use the inverse of this, sine, cosine, and tangent, to find those angles. So here we want to know what the angle theta is. And this one asks us to the nearest whole degree. So in order to do this, we get out our calculator. We make sure we're still in degrees, of course. And we will simply put in, instead of sine, we're going to find the button that looks like this. And we're going to use our alternate key, that little orange button. So we get the next level up, and you'll see that there's a little orange inverse of sine there. And what that turns out to us is we would put inverse sine in there and plug in our numbers, and that gives us, to the nearest degree when we round it, 23 degrees. Always checking that we round it, always rounding at the end if we are to round at all. And the same thing here, if we want to figure out what theta is, and we know that the tan of theta is 1/2, and remember, looking at this time, we're looking for 1 decimal place, then we plug that into our calculator. We can use our ABC button. We could use the decimal. We should come up with the same answer, that theta, I should have put a theta over here too, is equal to 26.6 degrees, because we're rounding to 1 decimal place. And then we want to find the value of theta here to the nearest degree. So now we've got, what have we got? We've got an opposite side, and we've got that thing, hypotenuse. So we're going to use sine, aren't we? So the sine theta is equal to opposite over hypotenuse over 6/10. So theta is going to be equal to the inverse of sine, 6/10. And we're asked to give this to the nearest degree, so we will make sure that is 37 degrees. That is what theta is equal to. Hallelujah.